going to be doing our own blockchain from scratch with Rust. I'm really excited about this. This is something that we've talked about doing a lot in our Discord channel, and it turns out it's something that we might be able to actually be able to build it. I think we really can build our own blockchain. We can build our own blockchain. We'll build it with Rust, and we'll build it with some common standard libraries, and we need to come up with like some sort of theme for it, right? Because all these different cryptocurrencies, they've got some sort of theme. Maybe it's like, there's StorageCoin where you store data on a disk, right? There's ComputeCoin, right? We get smart contracts. We could do whatever we want. We could build all of it. We could use our own. We could even we're going to build one from scratch, though. We're going to build our very own. We're not like a token, not like us off of a smart contract from like, boom, boom. Yeah, I know, right? Is it going to be cool? PubNub autocorrect. Wait. Is that how if I was to build Bitcoin, how would I build it? Then I was just kind of understanding and realizing, oh wait, I kind of already know how to do it. I think we're gonna try to build it. I think we've got all the pieces, the components that we need at our fingertips, and so let's actually get going. So cargo init, here we go. Let's start our coin. Let's see. I'll probably have to actually, you know what? I think we have to go back a directory, say cargo init. Can we do Steven? Can we do that? Is that works? Is this it? All right. Okay, we have it. All right, so by cargo, we need to add some dependencies. So I was thinking we should do a quantum resistant hash algorithm, right? Because with the quantum computers, it might take over. You never know. Hey, Astrid, how's it going? Welcome on in. We're going to be building our own Bitcoin. We're building our own Bitcoin with Rust. We're going to build it with Rust. I'm really excited about this. All right. So we've got, let's just jump into it. Here we go. All right. So I did have some libraries ready to go. I want to use this library here, which is check this out, post-quantum cryptography standard. All right. So this particular hashing algorithm has quantum proof. How is it quantum proof? So quantum computers are able to collapse and when it comes to cryptography, because if you can hash your secret key can be easily captured or recreated essentially with the knowing with the factorization. And this is the part I know about. The quantum computers can collapse possibilities into a single factor. Right? They can factorize large numbers. It's pretty simple to factorize regular size numbers, but very big numbers like 300-digit numbers are really hard to to factorize. Are you gonna use Ganache for local testing? Actually, that's a good idea. What is that? Ganache testing. Let's see. Ganache testing. Is this Ethereum blockchain? Oh. A quickfire, a personal Ethereum blockchain. So we're actually not going to be running on what is Ganache blockchain technology. Ganache is a personal blockchain that developers use to rapidly build and test Ethereum. Okay, so Ethereum's got its own network, right? Its very own network, its own consistency consistency algorithm. So is there decentralization? There will be, yeah. So that's the idea. So it will be a decentralized consensus algorithm. It doesn't matter how the data gets to where it needs to go. Everyone will have the same picture and they will all be able to agree because we're all going to have the same order of operations, right? That's the whole point of a consistent algorithm, is that it always is the same no matter where you are on the system. So we will be using, because this is a from the NIST post-quantum verified algorithm for cryptographic standards. And basically the idea is it needs to be quantum resistant, right? So we'll have a ready-made quantum resistant blockchain. So let's do that. Let's do it. And so our chain, so what are our block sizes and like the maximum size? We need to come up with some things like, what are the maximum size of the number of transactions that you had on a per block basis? And then what is the mining difficulty? I want to make it easy, right? I want to make the mining difficulty easy. So that way it's pretty straightforward. And then you can give rewards to the public address that's mining the block that finds the solution and then broadcasts the solution. So we need different channels of broadcasts as well. There's a lot of stuff to do, isn't there? I don't know. I'm starting to realize how much there is to do on this. It's quite a bit. All right, so what are some of our options here in this? We can always change it up. Avoid the 51% attack. So that is So yeah, the 51% attack is a problem. So we need to think about that. So not Owen, how do we do that? I've never even was under the impression that that has been solved. Has it even been solved? Is it solvable? If it is, then we can add it as a step in our algorithm. We could add it as a step in our algorithm. Maybe more than so. Maybe we have to say how much of the network has to agree, right? So we could say 67% of the network has to agree, things like that. If they start sell house hold quantum computer, this coin's gonna rule the market. No, it'll be quantum. It'll be ready for the quantum era. Quick question in theory: when it comes to Blick gain, if it's still small, how does it determine what is the right log, the right history would please be able to manipulate it? Oh, Torva, it's because it's a chain, right? It's a chain. So you can validate every single transaction throughout the chain as you go through. You can recheck that the signature matches. You can check that the signature matches. That's the idea. So you can use the public key in all of the chain items because there's always there's a block signature. And then there's a transaction signature. There's signatures everywhere. Everyone gets a signature. It's a lot of signatures. It's 67% need to agree, and a 24% never going to agree. That's an issue too. Gotcha. Very, very hard if 100% decentralized. Oh, yeah. See, I was wondering about that. I think that's a problem that we'll have to learn along the way. Right? So that's definitely, we got to put that on our list of problems. We got to put that list on the list of problems. Okay, so we've got our first. We also want Tokyo. So we want Tokyo. Let's make sure we get the latest version of Tokyo here. So let's go into crates, crates.io, crates, Rust. Let's go to Rust crates. Yes, I meant Rust crates. Crates.io, crates.io. QBR, is it QBR? That's what this is. But I guess we need. We can come. This is like the stand-in. This is the Stephen coin. I don't know what we might be able to call it something different, but I'm calling it Stephen coin for now. I'm calling it Stephen coin. So it's quantum resistant. Let's see. Features of Stephen coin. Features. What this is? We need to define the product specs, right? We got to define the product specs. If we were to save user data in blockchain and it's visible as binary, or we can see as hex, so anyone can see the user data like email. Drawing bows, yeah, that's totally up to us. So we could have, if we wanted to, well, I mean, technically, if you can store any kind of data within the data segment of the ledger, then you can put any is a set of bindings to the Lua programming language for Rust with the goal of providing a safe, as much as possible, high-level, easy-to-use, practical, and flexible API, starting with our Lua. Lua supports 5.4, including LuaJIT, and allows writing native Lua modules in Rust as well as Lua standalone mode. This is what I want. I want Lua in a standalone mode. I want it to be able to run. I want it all to be encompassed together. WebAssembly is supported through the... Oh, is it? Is it? All right, so this opens up some possibilities, yeah? I think it opens up some possibilities. All right, let's see here. Feature flags. 5.4. Lua 5.4. Okay, so let's see if we can grab that one. Let's see if we can add that one to our list. This is Lua. Lua is a scripting language. It's its own programming language. Is it similar to Vim and Emacs? Lua is completely separate. So Lua is an independent sort of a runtime that it's a very simple. So let's look it up here. What is Lua? What is it? All right. Lua is a power and efficient, lightweight scripting language embeddable into other applications, which is what we're going to do with our blockchain. It's going to be written in Lua, and we're going to make a lot of happy developers because Lua is very simple and clean. It's really easy. So if you take a look at this, let's kind of zoom in on it. So here's some of the syntax. It's pretty clean. It's pretty clean. So you've got your we're adding in all of our components. So we're going to have a Lua scripting engine for the smart contracts, right? So we're going to have smart contracts. There we go. Lua for smart contracts. We're going to have SQLite, which will be our ledger, the blockchain ledger. We need to define a schema with data and maybe a contract and maybe some other. We need to define what the schema looks like for that. Then we've got our async runtime, and then we've got our quantum resistant cryptography library. So it's going to have quantum resilience, even with all the quantum processors when they come out in the next 10 years or so. Okay, so I need to find the Lua. I need to find a Lua best Lua embed embed for Rust with eval. I want eval. I want to be able to eval. It says imlua, but I don't know about imlua. Imlua new. Oh, this is what we want. Here we go. This is actually what we're looking for. Perfect. Yes, I want this right here. Yes, perfect. I like this. This is what I want. Here we go. All right, let's open up our main here. Let's open up the main file. Let's go source main. Here we go. Let's go pipe that in. All right. Okay. Let's copy and paste some of this. This is what I want right here. This is what I want. This is what we're gonna do. All right. Here we go. Let's bring that out. Bring this in over here. Indent. Here we go. Looking good. We don't need hello world anymore. All right. Perfect. Let's see if we could build it. Okay. So we got some errors. What's the problem? Here? Failed but waiting for other jobs. Okay. Blah, blah, blah. Something. Oh, Pat, you've installed. Do we need like a Lua runtime? Cannot find 5.4 using pkfig. Could not run this. Okay. So we need to be able to. So this is one of the problems with Lua. What would be so nice is if we could have the Lua runtime. What we need to do is get this in a Docker container. That's what we got to do in order to solve a blockchain. Crypto HTTP. What? Okay, use this. What is a blockchain? So a blockchain is, think of a spreadsheet. Just think of a spreadsheet. It's a spreadsheet. Every single row has a signature that is based on the previous item, right? So it's a chain. So imagine you've got a signature, and the signature is cryptographically secure. So you've got a public key and a private key, and you use the public key can be used to validate. The idea is a weighted decentralized network. We assign trusted users. Users with a lot of activity, market share, and longevity and trusted value. There we go. So it's a weighted network. A weighted network. So we give extra weight to trusted nodes. This value is maxed, so we don't have a monopoly to decay with continued honest work. Okay. These weighted accounts have higher priority when validating hashes. Each node signs its own state of hashes, includes hashes from other trusted nodes, forming a web of interdependent signatures. Any manipulation required simultaneous alteration across multiple trusted histories, making attacks exponentially harder. Okay, got it. Together, these weighted cross-reference checkpoints create a resilient, self-regulating, and transparent consensus where influences is earned through consistent, proven reliability rather than sheer computational power. Got it. So we will use some human capability to assign extra weight to some specific nodes. I think this will nearly fully protect against the 51 features. AI distributed training. Sell your hardware to train and power AI models and get rewarded in coins. There you go. Get rewarded in coins. There we go. That's what we could do. So that is potential feature. That is a potential feature. So Lua scripting for smart contracts. So we got that. We got quantum resistant, Lua smarting, and then potentially distributed AI training. That's how we do it. That's how we do it. Okay. So we've got this, let's see, the 51% attack vulnerability. And then we can do something like this. There we go. How do we solve this? That is a potential there. Challenges to resolve. I think we have this. We'll use a weighted decentralized network to get started is what we'll do. Initially, that's what we'll do. Okay. So we've got what we have. I think we're good just to start. Let's see. How far do we want to get? Where do we want to get today? Where's our goal for today? We need to at least get things running here. So let's see, cargo. Let's do build real quick. What version? Let's do LuaJIT. Okay, LuaJIT. Let's just see. Let's just try LuaJIT. Because, right, I've got, which version of Lua do I have? I have LuaJIT 2. So crypto calculations are based on a consensus algorithm. The original blockchain or Bitcoin, it requires a sort of this, it's called hash caching, where you need to create a random signature, right? There's a random signature or random salt that creates the output signature with so many digits, marked. So I think we'll do like 5 just to be, because we're doing like Steven coin, right? So 5 looks like an S. Or we could do S because it will base 64 it, right? So we could do S. Number of S's. Why do 5? Why don't we just do S? That'll be it. All right, let's add that in. All right, so there we go. So our mining difficulty based on S. Uniquely based on the occurrence of the letter S in the block's hashes. Yep, there we go. See, that's what it is. The more S characters present in the hash, the lower the mining difficulty, making it easier to mine new blocks. Actually, it's kind of the more chars present in the hash, it's the opposite, right? It's the more difficult it is, the higher the mining difficulty, because you need more S's to match, because we're creating STB. Eddie Legendary, we could do St. Stephen's, economic friendly and new. I like that. Steven coin. All right. So we could also do st.b, right? Coin, which is secure trusted blockchain. We could do that one. That could be another one. All right. So we got some good name ideas here. We've got some good name ideas. So mining difficulty based on the number. Well, we'll base it on F or S, one of these things here. So between these things here. We'll figure it out. Could try to make an experiment PubNub style service that uses Steven coin miners to route PubSub messages globally. Hey, not Owen, you're talking about a presentation that I created many years ago. Latency might be nightmare to create though. Hey, it's actually okay because you can create. It's totally up to us on our consensus algorithm, right? We can decide what that looks like. We can decide what it looks like. So we need to define what a block looks like. We need to define what the chain looks like. So we need to create our schema. So we have our ledger for all the transactions, right? We need to also submit a dedicated. We need to find what do you call it? It's like if there's a bunch of transactions but they haven't been verified yet, so a pool of unverified transactions or candidate transactions is what we need, like a candidate transaction. There's going to be a lot of work to do here. I'm kind of realizing that there's a lot to do, and we need all the tools and stuff for it. Oh my goodness, there's a lot of stuff to do here. Are there actually a ton of things that have to be considered for the architecture? Yeah, there is. The good news is there's some stuff that will be easy. There's just a lot of decisions that need to be made. And tech token, or we don't want to call it token because it's not a token. This is a legit cryptocurrency. We're not going to be building an ERC20 token on the Ethereum blockchain. No, we're going to create our own from scratch. We're building our own. You called it technology. There we go. Quantum resistant technology. You got it. Okay. How does ownership work? I'm in a chain system. How do we know X liquefied money is mine? So it starts off with the seed wallet, right? And then the network itself can also generate, you can get rewards. And so it's all based on a consensus algorithm. Everyone needs to agree. Everyone will agree based on a set of order of operations that validate and verify all the transactions in the chain. Basically, think of it like a spreadsheet. Let's open up a spreadsheet. Is it sheets.new? Can we do that? Can we do a new spreadsheet? Here we go. Let's zoom in. Let's zoom in, everyone. Zoom in here really quick. Okay, so let's define our schema. So we've got our address. Let's see. Address, right? Your crypto address. You've got like maybe. So this is the schema. So it'll be like another address. Here's another address. So let's pop this up here. And then you've got your signature. Let's see. Amount. So maybe we could do like amount. Like the debit amount. So we say like 1, like 10. So this person has 10 coins. This person has 20. And this person has 30, right? And these are 3. So let's say John. Oh wait. So we'll have weird cow. Right, and then we'll have Mr. Dang Wall. There we go. And then we'll have not ON. Right, not wait. Let's spell your name right. Noto win. Not right. Note Owen. And then we'll have. We also have who else? We gotta have one other person. So we'll have Torva. There we go. We got Torva as well. So you'll get 40, and then you get 50. Right. Here we go. 40 and 50. So So this could be like our initial, and then we've got our signature, and then the signature is going to be a hash, right? Can we do that? Equals hash. Is there a hash? Is there like Google Sheets hash? Is there a hash function in Google Sheets? Hash of a cell. Can we do that? Utilities, digest. Oh, we have to do some scripting. Oh, yeah, we have to do some scripting. I don't wanna. I don't. We'll just. Can we do like? We'll do it based on. I've got an idea. We'll do it based on this. So, and it's always so it equals. Let's say the previous token, and then like you hash it based on some number that we all agree on, right? Although let's just do mod. Why isn't that working? That shouldn't that work? Divide. All right. Well, so it's based on some extra math. I want to do the XOR operator, but it's not working. The XOR operator is not working. So basically, that's the idea. So, and there's a signature. It's always based on the previous entry, right? So you've got the previous entry, and so there's no signature here, no sig as the very first entry, right? Equal no signature, or at least you say the first signature. It's going to be blank basically because it's the first one. And then what you do is you concatenate all the things from the previous signature, or at least the previous signature here, and then you use that as the seed into the next signature. And then you say the address plus the amount, and then you basically sign a, what do you call it? The previous entry. And then you do that for the next one as well. Then you sign the previous entry using the previous signature. And then that's your chain part. To block it up, then you would block these guys into groups. You'd cluster them, right? So you create a cluster. You still have a chain of signatures for each of them, but then you would cluster them together. And then you'd have the block signature, right? And then that would be like the same across the block, right? So then you have a different block signature here. So it's like signatures everywhere. Everyone gets a signature. And that's kind of how it works. And that's what we're going to do. That's what we're going to build. That's what we're going to build. Build. Boom. Let's build it. Okay. Problem. We got a problem. It's probably more Lua-JIT stuff, isn't it? Failed to run custom build command for Lua-sys. Something doesn't exist. All right. Most likely you need to install pkg config package for your brew install. All right. Well, let's just try this. We'll do brew install. We'll see what happens. We'll see what happens here. Copy and paste this here. Boom. All right. What's going to happen? I don't know. We'll find out. We're building our own cryptocurrency from scratch using in Rust, but we're just getting started. As you can see, this is all the code. We're just getting started. We got our libraries defined. We need to create our schema. The last thing I want to do is make sure that we get our Lua eval needs to work. We need our Lua eval working because that'll be our smart contract. That'll be our smart contract. Looks good. Looks good. Looks good. Okay. There's also a Lua load. So we could do this. So maybe we need to try this instead. Maybe we need to try this instead of eval. Let's do this. Let's do load and execute a chunk of Lua code. Maybe this is better. Maybe this is even better. Okay. I think let's try this. In string. Oh, response string. Lua return sleep. Okay. Oh, whoa. Check this out. This is neat. Okay. This is pretty satisfying. I like this. All right. So we need to do Tokyo main. Here, let's copy and paste this whole thing. Let's do this whole. Oh, nifty. Oh, cool. Okay. Let's do this here. Let's do this. I want this instead. I want to do this instead. I like this idea much better. All right. Set paste. Here we go. All right. This should work. I think this should work here. Let's close that window. Let's read the code really quick. Okay. So we've defined a function here in Rust with the Tokyo sleep, asynchronous. And then we've got Lua here, which allows you to call the sleep from within Lua. All right. Let's see if it built. All right. Let's see if we can build it. Is it going to build? It built. Cargo run. Is it going to run? It's going to sleep. Oh, wait. Did it sleep enough? It needs to sleep more. It should sleep. Return sleep ... What do you mean ... Oh, let's see. Sleep. Let's do 5,000. Let's sleep 5,000. Build. Run. Okay. It's working. It's doing what we want. You guys, it's doing what we want. Okay. How do we go about this? All right. So Lua load, return sleep. Can we load anything at any point we want? So we could. We could. What if we here? Let's do another one. Let's do another one. Okay, so let's see. Assert done. String is done. Does it return done? Okay, done. This is beautiful. This is so good looking. I love this right here. This is so satisfying. I am in love with this right now. This is exactly the code I want. What we need to do is commit this to a get init. Here we go. Get status. Get let's see. Wait, vi.get ignore. Do we have target? Okay, good. We are ignoring target. Perfect. All right. Get add all. We'll add everything. Get status. All right. Get commit. That's am. Initial coin set up and ready to build. Here we go. We did it. We did it, you guys. We need to create a repo. We need to create a repo. We can always name it something different later. GitHub. All right, let's make a new one. Create new repository. Here we go. New repository. It's happening, you guys. It's happening. Here we go. New repository. We'll call it. Let's call it Stephen Coin. Coin is a quantum safe cryptocurrency. There we go. It's a quantum safe I need to spell crypto right. Cryptocurrency. There we go. Quantum safe cryptocurrency. Is this cryptocurrency is 2 words. There we go. Quantum safe cryptocurrency with Lua smart contracts and maybe AI. We'll figure it out at some point. We'll make it public so everyone can see because you have to. It's open. So right. The blockchain is clear and clean. I don't know how to keep my network safe from that. Usually tutorials don't mention this vulnerability. You gotta be careful. The possum tails. Torva, funny gimmick coin idea. You can let your hardware be used by an AI to research the true meaning of life. It's one giant block. So only when the problem is solved, people who contributed will get a share. Oh, that's definitely a meme gimmick. Yep. Because no rewards anywhere until the answer to life is solved. And then rewards for everyone who invested. There you go. That'll be a good one. All right, let's create the repo. Let's create the repo and then push our code. Here we go. Pushing our code. Boom. There we go. Push main. It's there. It's live. There we go. The beginning. So we got name ideas. We got features. Quantum resistant. Lua scripting for smart contracts. We've also got what else here? AI distributed training. Maybe we'll do that. And then our 51 attack vulnerability protection approach that we got from Torva. Thank you, Torva. We'll be using that a weighted decentralized network to assign trusted users or trusted, servers. Basically, is the idea. There we go. We're gonna need our trusted servers. So we got it. We got up and running. There we go. So we got started. We did day 1. We got everything running. Basically, we've got our. So this is our main. So we've got Lua running. We didn't do a hash. So we should do some hashes. We'll be back tomorrow, and we will be doing more building. We'll continue building our own blockchain from scratch.